Today, we will learn about the Moivre's theorem. So we should know how to convert a complex number, which is in a plus bi form, into polar form. So in polar form, it's r times cosine theta plus I sine theta. R is the radius, theta is the angle. So de Moivre's theorem states that this complex number, what if it's raised to the power n? If it's raised to the power n, it equals r to the power n. We are raising the radius to the power n as well, times cosine n times theta plus I times sine n of n theta, sine of n theta. So if we raise a complex number to the power n, the Moivre's theorem states that we can convert it to polar form, and it will be the radius to the power n, and we are multiplying all of the thetas by n2. So cosine n times theta plus I sine of n times theta. So what if this complex number is raised to the fractional power? In other words, to the nth root. What if it's raised to the nth root? So it's very similar to this one, but it's a bit different. So we also raise r to the nth root times cosine of, I'll put a parentheses here to make sure we don't get confused. The same as cosine of theta plus 2 pi k over n. Now what is this k value? I'll explain that later. So cosine of this plus I sine of the same thing. So it's theta plus 2 pi k over n. This formula might look a bit complicated, but it actually is not. So what we're doing is, if it's raised to the nth power, let's say square root, we also raise the radius to the nth power, but then we're finding the cosine of theta plus this 2 pi k over n. This n comes from the nth root, and same thing for the sine. So First of all, to make things clear, this 2 pi, we know in a circle is equal to 2 pi radians or 360 degrees. So this 2 pi, it only works if your theta is in radians. If the theta is in degrees, instead of 2 pi k, we can also do 360 degrees. If the theta is in degrees, then instead of 2 pi, it'll be 360 degrees times k. If it's in radians, then we just add 2 pi. Now, what is this k value? So this k value is it's just 0, 1, and it goes on until n minus 1. What do I mean by this? Let's say n equals, let's say 4. N is raised to the 4th root. So since n is raised to the 4th root, this will have 4 answers. So we plug in 0 for k, we find one of the answer, then we plug in 1, and then compute again to find another answer. So in this case, k would be 0, and then you plug in 1, and then you plug in 2, and then n minus 1, so 4 minus 1 is 3, and then you will plug in 3, and you will get 4 different answers. So that's it. You have to remember all of these formulas. This is the Moivre's theorem. You should already know how to convert a complex number to polar form, and then you can apply the Moivre's theorem. Let's look at an example. So let's say I told you to find the square root of 3 minus I to the power 4. So first of all, we will convert this to polar form. So we know the polar form is in polar form of any complex number is r times cosine theta plus I sine theta. Let's find the r first. So the radius equals square root of a squared plus b squared. Here the a squared, the a is the real part and b is the imaginary part. So this equals radical 3 squared plus negative 1 squared, because we know there's an imaginary 1 here. So negative 1 squared. We know the square root and the square cancels out. So r equals square root of 3. And negative 1 squared is just positive 1. So 3 plus 1, which equals square root of 4, which is the same as 2. Alright, so now we know our radius, which is 2. Now let's find our theta, our angle. So to find our angle, we simply just find the arctangent of b over a. As we know, B is the imaginary part and A is the real part. So we're finding the arctangent of radical 3 over 1. So you can use the calculators. So make sure your calculator is either in degrees or radians. Just make sure in which format it is set in. If you want to find the answer in degrees, you should get negative 30 degrees. And this is the right angle because if we try to plot this complex number on an imaginary plane, the horizontal is the real part and the vertical axis is the imaginary part. So the real part, square root of 3, is positive, so it's should be somewhere here, somewhere between 1 and 2, and negative 1, the I, which is basically negative 1, is down here, so in the fourth quadrant. So, and negative 30 degrees is in the fourth quadrant. So this is the right angle. You can write it in positive too, which would be, all you have to do is add 360. If you add 360, this is the same as 240 degrees. So any of them works. So now we have our theta. So now it's 2 times cosine of negative 30 degrees. If you wrote it in radians, that's also okay. Radians also work. Plus I sine of negative 30 degrees. So now we have our polar form. Now we use de Moivre's theorem. So in de Moivre's theorem, the polar form for this is what we mentioned before, 2 times cosine of negative 30 plus I sine of negative 30 degrees. And since this is raised to the power 4, we also raise this to the power 4. And de Moivre's theorem says this also equals 2 to the power 4 because radius to the power 4 times cosine of negative 30 times 4 plus I sine of negative 30 times 4. Degrees, don't forget that, it's in degrees. Now 2 to the power 4, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 16 times cosine negative 30 times 4 is negative 120 degrees plus my sine of, again, negative 30 times 4 is negative 120, so negative 120 degrees. Now, we just compute these. So cosine of negative 120 is just negative 1/2 plus, we have our I, and sine of negative 120 is square root of 3 over 2. I just know this because I know the unit circle. Sine and cosine of negative 120 is the same as sine or cosine of 240. Now we just distribute. So 16 times 1/2 is 8, so negative 8 plus 16. Oh, I did a mistake. This should be a negative. It's not positive. So 16 times 16 times negative radical 3 over 2. We know this and this cancels out, and this becomes 8. So it's just minus 8 radical 3. And we know negative times positive is negative. Well, let me write this. Don't forget the I. So this equals negative 8 minus 8 radical 3I. This is the answer. The exact answer to radical 3 minus I to the raised to the power 4. And this is how we use de Moivre's theorem to find a complex number raised to any power. Let's look at an example finding a root of a complex number. Let's say a complex number 1 plus square root of 3I. Now I'm telling you to find the fourth root of this complex number. So what would you do? Of course, you will use de Moivre's theorem. So first, let's convert this complex number to polar form. So r equals square root of 1 squared plus square root of 3 squared. Now we get square root of 1 plus 3, which just equals square root of 4, which equals 2. So now we know our R value is 2. Now we need to find the angle theta. So we know to find theta, we find arctangent of B over A, in which in this case it's radical 3 over 1. So this equals 60 degrees. If you put it in calculator, it will say in 60 degrees. You can also write it in radians. So it would be pi over 3 radians, but whichever one you prefer or your teacher prefers. So now it's 2 times cosine of 60 degrees plus I sine of 60 degrees. So now we have our polar form. Now it's time to apply the De Moivre's theorem to it. You have the formula for De Moivre's theorem from the notes before. You should know this should equal the fourth root of 2 times cosine of 60 degrees over n, which is 4, plus, since our theta is in degrees, we, instead of 2 pi k, we do 360 degrees times k over the n value, which is 4, right? So, and then plus, well, let me put a parenthesis here so that it's not confusing, plus I sine of the same thing, 60 degrees over 4 plus 360 degrees times k over 4. So now we need to find the k value. So the k value equals 0, of course, first is 0, 1, 2, and since our n value is 4, so 4 minus 1 is 3. So this is where we stop. So we need to plug in each of these 4 values to the k, and then we will get 4 different answers. Now we have all the information. So now it's time to compute. We can keep the fourth root of 2 as it is. You can also use the calculator to find the answer and round it up, but let's keep it exact for now. Cosine. Cosine of... Now, if you notice, we can divide this. 60 divided by 4 is 15. So 15 degrees plus... Now, if you notice, We can also divide both the numerator and denominator by 4. So 4 divided by 4 is 1. 360 divided by 4. So 4 times 9 is 36, and then 0. So that just becomes 90 degrees. 90 degrees times K plus I sine of the same thing, because theta is the same for both of them. So it will be 15 degrees plus 90 degrees times K. So now we simplified our formula a little bit. Now all I have to do is plug in each of the values of K into this and get the answers. So let's plug in 0 first. So this will stay as 4th root of 2 times cosine of 15 degrees plus 90 degrees times 0 plus I sine of 15 degrees plus 90 degrees times 0. So we know 90 times 0 is just 0. So this will just end up being 4th root of 2 times cosine of 15 degrees plus I sine of 15 degrees. Now this is one of the answer. But we are not done yet. Now we need to plug in 1 to our answer, 1 to the formula again. And by the way, we can just keep the answer in polar form. If you have to convert it to rectangular form, just use your calculator to plug this in your calculator and you'll find the answer in rectangular form. Otherwise, you can just keep it like this. I will keep it like this for now. So now let's plug in 1 for our K value. Now it's cosine of 15 degrees plus 90 degrees times 1. plus I sine of 15 degrees plus 90 degrees times 1. So 90 times 1 is just 90. 90 times 1 is just 90, and 90 plus 15 is 105. We just get fourth root of, oh sorry, it's a fourth root, it's not 2. So it's just 4. Fourth root of 2 times cosine of 105 degrees plus I sine of 105 degrees. Here we get our second answer. Now we need to plug in 2. It's all the same thing, except we plug in 2 for the k value. Fifteen degrees plus 90 degrees times 2 plus I sine of 15 degrees plus 90 degrees times 2. So 90 times 2, we all know is 180 degrees. 180 plus 15 is 195 degrees. So it's not that complicated, it's just plugging in the values, first convert it to polar form, then plug in the n and the k, and then just find the answer like that. So now it's cosine of 195 degrees plus I sine of 195 degrees. Here we got another answer. Now we got our 3 answers. I'll remove this. Now let's get our final answer. So fourth root of 2 times cosine of 15 degrees plus 90 degrees times 3. plus I sine 15 degrees plus 90 degrees times 3. Now we know 90 times 3 is 370 degrees. 370 plus 15 is 285. It's all the same thing. Cosine of 285 degrees plus I sine of 285 degrees. And here we go, another answer. As you can see, we plugged in all of the values and we got 4 different answers. You can leave these in polar form, or you could plug it into the calculator and find the answer in rectangular form. That's all you have to do. I know this is tedious, but if you notice, we're just adding the theta by 90 degrees. Like, that's all we are doing. So if you keep doing more of these problems, you'll get the hang of it and you'll see some patterns. So it won't be as tedious as I did. So that is all for today. This is the Moivre's theorem. It allows you to compute complex numbers if they are raised to the nth power, or find the roots of a complex number. You can also use it for other numbers, but today I just showed you how to use it for complex numbers.